into triangles. And guys, we're going to start our unit now into triangles. And like I said, none of this is new to you, especially for today. We're going to start out a lot of the stuff again with algebra. We'll get to some of the proof stuff maybe later on this week. The proof stuff that we will do within triangles are actually, I believe, easier. Ladies, please. Are easier than what we were working on before, because there are certain scenarios and things we set up to work with. So they work out rather quickly. But like I said, we're not going to get into that today. We will finish that out. Probably start with that on Wednesday. What I want to do today is start talking about triangles. Yes, sir. After first semester. Second semester has no proofs. This is basically the last chunk of things that have proof. We don't, after chapter 4, there really isn't all that much proof left. There's maybe a handful of them. We're at the crescendo of them. We're at the very top of where we have to be for the amount of proofs we'll do, and then work our way out. So, what I want to do here is define a few things. What is a triangle? How do you make a triangle, guys?
3 points.
Okay, you have 3 sides, but what do you have to make it even better? They don't have to be. A 3-sided shape. Well, here's a 3-sided shape. Could be, couldn't it? Triangle's made up of 3 non-collinear points. Three non-collinear points enclose a triangle, if you want to think of it that way. I heard someone say that a second ago, the sum of the interior angles of a triangle is always how much? 180, good. The sum, bless you, of the interior angles, bless you, is always 180 degrees. Okay? If it has more degrees than that, it's not a triangle. If it has less degrees than that, it's still not a triangle. You are able to classify the triangle by either its side lengths or its angles. I know that you guys have all done this before. This goes by real fast. So you can classify, which means what type of it is it. And sometimes you can mix between the two. For example, give me a type of triangle. Isosceles, okay? Isosceles. An isosceles triangle is what kind of a triangle?
Isn't it 3 congruent sides?
No. Isosceles triangle, 2. An isosceles triangle has exactly 1 set of congruent sides. Okay? An isosceles triangle has 1 set of congruent sides and 1 set of congruent base angles. So what happens when you're dealing with an isosceles triangle? Yeah. What's that? Yeah, absolutely. Yes, sir. Yeah. The reason make one, I thought I told you to grab that too. Yeah, you can use both of those. So what happens here is with an isosceles triangle, when you have your side lengths that are congruent to one another, when you put your tick marks in, they're kind of pointing at what are called base angles. Okay? The 2 angles that are not between the sides that are the same are always going to be congruent. Those are called base angles. They don't necessarily have to be on the bottom. They can be on the sides. It can be up on top. It just depends on how it's drawn. So isosceles triangle has 1 set of congruent sides and 1 set of congruent angles. Yeah, I'll get them back to you. I'm not doing any proofs today, so I don't have to worry about it. I'll get it back to you guys when I get all the test stuff, and I'll get it all back at the same time. Oh, no problem.
Oh, just you know the movie thing that's on Thursday?
Okay.
How do you know if you're...
Not a clue. It's above my pay grade.
Because I haven't gotten a check by
I don't know. I don't know. So, guys, like I said, I don't have much to go through here today. You guys are going to have a few problems for homework, and first hour is going to get out and get pretty much all of it done. So, you have isosceles triangle. A lot of times I just write it as this, ISOS triangle. I just use that. Abbreviate. Why spell everything out? Kind of silly. Okay. So an isosceles can be classified by its sides or by its angles, because if you have base angles, then you'll have sides congruent. If you have sides congruent, then you have base angles congruent. Ladies, please stop talking. Thank you. What's another type?
Scalene.
Scalene, okay. Scalene. What's a scalene triangle?
A triangle that has 3 sides.
Well, they all have 3 sides, thank you. No sides the same. All sides are different. No congruent sides. So a scalene triangle is just going to be 3 different side lengths. Okay. 3 different side lengths, that's all. You can have a scalene right triangle. That's possible.
Oh, I do that.
Okay. Because remember, you can mix some of these together. Okay, you can mix some of these together without too much of a hassle. Scaling triangle, obviously we said that no sides are the same. A right triangle is very easy. What do you know about a right triangle?
That's a right angle.
Very good. How many right angles?
1.
A right triangle has 1 right angle. If it has 1 right angle, how many degrees are left for the other 2? 90. So that means that the other 2 angles in a right triangle are always complementary. It's one of those little tricks. You don't have to always use that, but it's something that's easy to look at. Within a right triangle, you can have an isosceles right triangle. If that's the case, you would do this. If those two sides are the same, that means the base angles that are across from them, are also the same. So if all these are 180, subtract out 90, you're left with 90 for 2 of those. What are each one of those measuring? 45. So this is one of the first triangles that we deal with, is kind of like the basis of trigonometry. The 45, 45, 90 triangle. It's a right isosceles triangle. The other one that we'll look at is the 30, 60, 90 triangle, which is an scalene right triangle. Those 2 triangles basically make up all of a good chunk of second semester, as well as when you guys get to Algebra 2, it pretty much takes up a couple of months worth of trigonometry. It's the whole basis of what we call the unit circle and everything like that. Okay? So right triangle, 1 right angle. The other 2 are always complementary because they have to add up to 90. You can have a mixture of isosceles right triangle. You can have scalene right triangle, and so on. What's another triangle? Equilateral. Good. Equilateral. The equilateral triangle, from the word equal, lateral. For lateral meaning sides.
Is it lateral or like lateral?
Lateral.
Okay. You put no. Okay, imagine.
So, equilateral triangle has your 3 sides that are the same. And if it has 3 sides that are the same, that means you're going to have 3 angles that are the same. Correct. So, equilateral triangle has all 3 sides congruent. And all 3 angles congruent as well. And just like you said, all 3 of those angles always add up to all 3 of those are always 60 degrees. Each one of these will be 60. And like I said a second ago, when you have an equilateral triangle, if all the sides are 60, or excuse me, all these are 60, and these sides are all the same, if I draw this down, what's called the perpendicular bisector, That makes this angle here 30 degrees, and you get this ratio of 30, 60, 90, where you're always going to get this side will be 1 times x, this is going to be x root 3, and this will be 2 times x. There's a ratio of the patterns, the sides that occur. And like I said, that becomes the basics of trigonometry, SOHCAHTOA, things like that. Okay. What's that?
So that looks so confusing, but once I get there, I'll get it.
It's not. It's a matter of remember. As long as you remember the term SOHCAHTOA, it's pretty easy. It is. I'll tell you about that later. So let's see. We had what about angles? How can you talk about triangles via their angles? We've already talked about all of them with the sides, and we did one with right angle. What about what's another one you can do for angles? Give me a type of angle. Acute. Could you have an acute triangle?
Yeah.
Okay. You can have an acute triangle, obtuse triangle. We already did that one. An acute triangle. An acute triangle is going to have all 3 angles being acute. Yeah. So think about that, the triangle we talked about a second ago, the equilateral. The equilateral one is also what we call equiangular, because they're all equal angles. So an equilateral triangle is an acute triangle. So, like we mentioned, you can have multiple classifications of a triangle. It's very, very common. In an equilateral, yes, there will all be 60. One could be 50, one could be 60, the other one could be 70. Obtuse one, yes, sir. The what? Yeah, it's only for right triangles. Yeah. The obtuse angle has one, or obtuse triangle has one obtuse angle. Because can you have more than one obtuse angle in a triangle? Nope, you'll run out of degrees. Okay? Because obtuse triangle, or excuse me, obtuse angle, an obtuse angle is more than 90. Please put your phone away. You do it all day long. Please put it away. Thank you. As soon as you have an obtuse angle being over 90 degrees, just say 91. If it's going to be a triangle, you only have 89 degrees left to go. So you can't have more than one obtuse angle. It won't work.
Where's the obtuse angle on the right side? I don't see an obtuse angle on the obtuse triangle.
I'm not drawing it, I just used the triangle, that symbol just instead of writing out the word triangle.
Okay.
That's all. I didn't draw an acute one either. Oh, but I see what you're saying, yeah. I use that symbol just to show triangle. That's
Gotcha.
all. Other than that, I mean, like I said, this is stuff you guys have all seen. This is stuff that you guys have all seen. As well as the following. What's called the exterior angle theorem. We did this last week. We did a proof like this, where I said that this outer angle is going to be equal to what?
The sides of the triangles added up, right?
Right, very good. This exterior angle is called rephrase that. An exterior angle is an angle that's on the outside of a triangle, or outside of any shape. You can always get exterior angles. This exterior angle will always equal the sum of the 2 angles it doesn't touch. And we did the workout of the proof of that last week when we talked about, I think we did congruent supplements, I believe. So the exterior angle theorem is, there's a lot of words to this, is basically the exterior angle equals the sum of the 2 angles it does not touch. That's it. It's the easiest way to write it. The exterior angle equals the sum of the 2 angles it doesn't touch. So if this is 55 and this is 40, what does it make? How many degrees are left for here? 85, good. That means there's 85 degrees here. What's 85's supplement?
Yeah, how'd you get any, I think 95.
Let's start over. How many degrees are inside of a triangle?
180.
180. What's 40 plus 55? 95. So subtract 95 from 180, you're left with,
Yeah, that's why I was confused.
which means the supplement to it is,
Oh.
which means this angle equals the sum of the two it doesn't touch. Some days. Like,
Love being a nice man.
all right, solve it. Solve for x. No, it's x.
You want
Negative,
X?
solve for x, please.
Done. Really? Who told us? What, like Edgar? Because apparently Edgar told Charlie to. Equals 75. Or x equals 5. Wait, no, it's not. That's not. X equals 75. No, you don't need to do that. Is x equals 75?
Oh, I haven't done it yet.
No, how did you just no? It's
So 2x minus 5 is 70 plus x. Some very,
Plus X.
That's all I got.
the sum. The word sum means add.
Yeah. X
So
down.
quick math. Move the x, move the 5. You got x is dun dun dun. Boom.
Kevin was right. What the heck?
So again, notice if that's 75, what's 75 and 70? 145. What is the supplement to 145? What's 2 times 75? 150 minus 5. Dun, dun, dun. Hooray, math. Okay? That's how these things work. Yes, sir?
Do you have to find like each
What do you mean? Oh, the degree measure?
angle? Yeah.
No, I'm just showing you how it works. That's all. I'm just walking myself through it to make sure that I did it correctly. It's one way to check your work because you know how many degrees are in a triangle. It takes a second to substitute. Okay? Let's try another one. All right, do those two, please. Angles. Which means you would get 4x plus 8 is 2x plus 3 plus 51.
Oh, I did that right. Yes. Thank you.
Wow, congratulations.
Yeah.
So move the 8, move the 2. You get 2x. What is that? 46.
And then it's
46. On the other side, same deal. I'm just going to kind of go through this one a little bit quicker. I want to give you guys a little time.
I didn't hear Murphy.
It's all right.
Mr. Murphy.
Yes, sir.
Is this guy dying?
No, he's not dead yet.
Okay.
He's not doing well.
Who?
He's had some health problems. The fridge.
That's his daddy. That look like a
They look just alike.
Hey. Hey, don't he look like his son? They look alike and it's weird because they do.
Anyway, moving stuff around here, we're going to get X.
Smile. The same little dude.
You will notice, ladies and gentlemen, come on. You will notice that most of these problems are very easy. Okay? Just be careful when you're simplifying stuff through. You get 22. Okay. I just want to throw through a quick example of sometimes when you have a multiple angle problem where you have to kind of work your way out of it. Is it this one? That's this one. Sometimes you're going to wind up with something where you're going to have a larger diagram. You don't have to write all this out, but just so you see. Sometimes you'll have a larger diagram where you'll have to try and solve through a bunch of angles. The easiest thing to remember here is that when you do that, your best bet is to always pick a spot that looks like it's going to be easier to work with. For example, if I'm looking at this one, would I want to work in this triangle down here? I have a 20 degrees, a 2, and a 3.
Yeah.
Why?
It's like not as much. Like that is like clutter.
Okay, but you're not going to be able to solve for anything because you don't know any angle measures. If you know 2 angle measures, you can find the third, right?
Yes.
That's the idea. Pick a spot that makes sense to work your way out of. So in the other case, you would have to start up here. What's 45 and 65? 110. What's left over for a triangle? 7. So you get 70 here. 3 angles form a what?
800.
They form a line. So if I do that, subtract out the 70, subtract out the 45.
From 125, 125
Oh, 115.
Oh, 115 minus.
So you got your 65, and then you work your way out. All I'm saying is that for big picture problems, just pick a spot and go. Okay? Some spots are a lot easier than others. They're really not that difficult. Okay? I did this on the calendar. I already have the link to the book page. What I have you guys doing is 4-1 in the book. I believe it starts on 14. It starts on 14. I have you going through, I want to say 36 or something, right?
The number 14 or page?
Number 14. Yeah. I had you guys going, this is 4.1 in the book. Is it 326? I'll check the page. I know, I don't remember if it was 326 or 221. I was way off.
Oh, I guess that's a little much.
All right, go ahead and get started on that now, guys. I will pull up the. I will pull up the actual page to at least get the first couple started up on there. The rest of them are really fast. Like I said, the link to the book page is already on the calendar. So if you click on the calendar where it says more details, you can go from there. Let me show you how that works again, because a lot of you guys still have a tendency of not knowing how to use it. So if you are, oh, wrong one.
Oh, I found that site.
If we're here, shh, guys, come on. I don't want to have to re-explain this more than once. Obviously, we're here where it says more details. There's your description. Oh, I thought I had it linked. I guess I did not have it linked. All right. Do you guys remember how to find the book on here? Where you click Geometry Chapter 4.
Go to Algebra 2 Honors.
Hey, look at this. Here's the tab to open Chapter 3 and Chapter 4 from the book. Wow. Gee, where do you think you're going to click?
The book page.
This little.
This thing here. It'll have a little pop out eventually. Yeah, just click on that and it'll pop out then. And then just scroll back down. All right, you guys got problems to do. Let's go.
Can you make it bigger? I don't have my.
That's all I got here. Yeah. I will say one thing when you guys get down. I will say one thing when you guys get down to the problems down here on the bottom. You're probably gonna have to find all the angles to make them work. Okay. There you go.
Wait, is the directions?
Solve for x.
These outside angles. So these one here were 40 and 55.
Come on, guys. Shouldn't be hearing a lot of stuff. Should be working. There's not much going on here, so let's fly through it.
That was last week.
Click on the geometry. Just hover over the top.
I had my clothes on, so I have some but like now,
And this actually refreshed my page.
I feel best.